class, today we're going to be talking about ratios and proportions. So we're going to go ahead and take a look at, first of all, what is a ratio. And a ratio is basically a way that two things might relate to each other, and it's often written as a fraction. So you might hear that something has a ratio of 2 to 1. That could be written as 2 over 1 like that, or sometimes we write them with a colon. That would be 2 to 1 like that. And it's just going to give you an idea of how you want to deal with the two items. Like you might be mixing some solutions for chemistry where you have to mix them 2 to 1. So you have 2 of one item for every 1 of the other item. Now, when we're dealing with ratios, another way we might write it is actually just writing it as 2 to 1. When it's written like that, or it's written as 2 per 1, or whatever you might end up having. Normally it's not 2 per 1, it'll be like 2 miles per 1 gallon or something like that. Normally the per is dealing with a rate where you actually have units on your item. But when you're dealing with it written like this in words, what you want to keep in mind is the first number that you have here, which is also the first number when you're dealing at it written with a colon, is always going to be the top of your fraction. And the second number is always going to be the bottom. So keep in mind, depending on how it's written, that the first number is what you will typically put on the top of the fraction, and the second one will be on the bottom or in the denominator. Now, when you're dealing with ratios, we often deal with what's called a proportion. And a proportion is basically when you have two fractions that are equal. You may have seen statements before written where 1/2 equals 2/4. And this is a true statement because 2/4 does reduce down to 1/2. But you also might have equations where you actually don't know what some of the values are. For instance, you might have 20 over x equals 4 over 3. This is a proportion where we have an unknown that you see right here. Now, we can deal with this in the way that we dealt with solving problems that were equations with fractions, and just multiply by the least common denominator in order to eliminate our fractions. The least common denominator in this case is 3 and x, or 3x. But there is a much easier way to solve this, and that easier way is what we call cross multiplying. When you cross multiply, what you do is you multiply diagonally, and what you end up with is the result after multiplying by the least common denominator. So we're going to multiply diagonally here. So we're going to do 4 times x, which is 4x. Notice I did that diagonal and I wrote it directly underneath where the bottom of the diagonal is. That sometimes helps people. And then you carry down the equal sign, and then you multiply the other diagonal and write it down, and 20 times 3 is 60. What you end up with is the result that you would get after multiplying by the least common denominator, and you also end up with an equation that's much easier to solve. So for instance, on this equation, to solve it, I would just divide both sides by 4. The 4's would cancel into a 1x, and 60 divided by 4 is 15. We can check this by replacing this x up here with that 15 and see that 20 over 15, if we were to reduce it, it would actually equal 4 over 3, because we would actually divide the top and bottom here by 5, and 20 divided by 5 is the 4, and 15 divided by the 5 is the 3. So you can see that it actually works. Now, some proportions aren't quite as easy as this one, but you can still use the same basic process. For instance, we might have something like x over 7 equals x plus 5 over 5. Now, this particular problem, again, is a proportion. It's not quite as easy as the last one, but we're still going to use the same process. I'm going to multiply this diagonal, and since we have more than one term up here in this top part, I'm actually going to just write that down as 7 times x plus 5. Notice we're going to have to come back and distribute. Then carry down your equal sign, and then multiply your other diagonal. And x times 5 is 5x. Let's now distribute to solve this. So we get 7x plus 35 equals 5x. Now we need to get our x's on one side, so we will subtract 5x from both sides. These cancel and make 0 on that side, and over here we have 2x plus 35. Now to solve, just like in a basic equation, we would need to move the 35, and it's positive, so we'll subtract 35 from both sides. And 2x ends up being negative 35. And finally, divide both sides by 2, and x ends up being negative 35 over 2. So that's how you solve proportions. Now, proportions are very, very helpful when we're dealing with certain situations in problem solving. So let's say that you have a situation where you're trying to compare prices of something. And let's say that you have a 10-ounce can of beans. And let's say that that is selling for $1.50. And you would like to know how much, if we're being charged the same cost per ounce, should a 16-ounce can of the same item be costing you. So we don't know the cost of this 16-ounce item. Now, one key word that I said here just a minute ago was that we're basically wanting these two items to be the same cost per ounce. Notice that I said cost per ounce. When you're dealing with our ratios and our proportions, if you're written like this, the value that's before the per will be on the top of the fraction, and the value that's after will be on the bottom. So if we look at making a ratio for this first can, that ratio would be $1.50 over our 10 ounces, and that would be the cost per ounce for that first can. We want that to be the same as, which means equal to, the cost, which we don't know, on our second can over the 16 ounces of our second can. Notice we've just set up a proportion that we can solve using our cross-multiplying method we just found. So let's go ahead and multiply our first diagonal, which gives us 10x, and then carry down our equal sign, and then multiply our second diagonal. And our second diagonal is going to end up being 24. Now, we need to solve this, so we're going to divide both sides by 10. And the cost of this second can should be $2.40. So that's one area that we can use these ratios and proportions. Another area that we can use these is with similar figures. Sometimes you will see triangles that are considered to be similar. For instance, we might have something where we have a triangle like this, and it is similar to this triangle here. Maybe you put the first triangle on a photocopy machine and reduced it down to being the size of the second triangle. That means that the sides that correspond will be proportionate. So let's say the sides of this first triangle are 4 inches, 3 inches, and 5 inches. The next triangle, let's say that this particular side right here happens to be 2.5 inches, and we don't know what this side over here is, and we would like to know what it is. And let's say that we also don't know what this other side here is. We'll call it y. Well, notice that if we compare this one to that one, they correspond to each other because they are the same in the same orientation. We'll just assume that these were set up and weren't rotated at all. So this 5 inches compares to this 2.5 inches the same way that this 4 inches should compare to the x. That's going to help us set up a proportion that would be 5 over 2.5 equals 4 over x. Notice that the values that are in the numerators are both from this first triangle, and the values in the denominators are both from the second triangle. Similarly, we can set up another proportion for the 3 inches and the y, and that would be 5 over 2.5 equals 3 over y. Notice in each proportion we used the ratio that we knew both values for. That made it so that there was only one unknown in each of the proportions. Now let's cross multiply and solve each of these. 4 times 2.5 is 10. And then carry down your equal sign. 5 times x is 5x. Now divide both sides by 5 and we find out that x is 2 inches. Now let's go ahead and take a look at our next one. Multiplying this diagonal, we get 7.5. Carry down our equal sign. And then multiply this diagonal here and we get 5y. And now we just need to solve. So we'll divide both sides by 5 and we find out that y is 1.5 inches. And now we know the dimensions for the other two sides in this other triangle that was similar to our first triangle. And that is how you're going to be dealing with your ratios and proportions and how you solve the proportions.